Hello everyone, let's talk about meteorological data. While doing calculation for any part of the world, you're going to need the weather data of that particular city or city nearby. For instance, let's say if I'm doing calculation for Bangladesh, and let's say certain city like Dhaka, I must get all the weather data which I'm going to use for my load calculation and all other calculation and selection of cooling tower and chiller and everything. To make your life easy, you can refer to this website ashrae-meteo.info/v 2.0 slash. So if you go there, you'll get the Ashrae database for weather. Basically, Ashrae have collected all the weather data from different airports, and whenever you see a airport, you get data from the city. We get data for 4 years, like 4 different years. For 2009, you can get the data for 2013, 17, and 21. Again, you can get the data in SI and IP. If you are more familiar with inch pound, you can go for inch pound. And if you're going for SI metric, you can go for SI metric. It's very easy to use just by clicking left of your mouse, and if you hold it, you can hover the whole map of the world. And if you scroll, you can actually check the no, you can zoom in actually. Now, if you want to get data from like this part of the world, if you right click, then at the left bar here, you are going to get nearest weather data. For instance, as I have left click in here, I got the data here for Dhaka, and then for Agartala, the second one, and then the nearest one is A, the second nearest one is B, third nearest one is C is Kolkata, and the fourth one is D, Chittagong. So for now, I have to select at least one weather station. So let's click the nearest one, A. Now, as you have selected A, you're going to get all the data of this weather station, all the data to make your life easy. And eventually, you can print it out by clicking bottom right corner. There you see printer here, and print out and save the whole data. Now, if you come here and check it out, we have data for Dhaka Hazrat Shahjahan International, Bangladesh. The code is WMO Station Identification Number, World Meteorological Organization 419220. Latitude here, longitude is given. Elevation from sea level is 30 feet. And then external pressure 14. External pressure at the station is 14.68 psi. Time zone is 6. Then year is period calculation design conditions and the other data. This Bureau of Army and Navy number. And it's not relevant for us. Okay, we get annual heating and humidification and ventilation design conditions. So for the design of annual heating system, humidification system, and ventilation system, you can use this portion of the table. And if you want to design annual for the cooling and dehumidification and enthalpy design conditions, here we have the data for that. Let's read it one by one. When it comes to annual heating and humidification, we get the coldest month is only 1 month. And heating dry bulb temperature, you said dB goes for dry bulb. At 99.6% time, it's 55.1 degree Fahrenheit. And 99% time is 57.1 degree Fahrenheit. So more if it is more precise, like 99.6% is more precise than 99%. So more the precise is, the less the temperature would be. So 99.6% time it is 55.1 degree Fahrenheit or more. Okay, humidification dew point and mean coincident dry bulb temperature. We have dew point here for 99.6% is 45 degree Fahrenheit, and then humidity ratio in moisture per pound of dry air 44.2, and mean coincident dry bulb is 75.2. You can actually use either 99.6% or 99%. However, I always personally recommend to use 99.6% because you're designing your system today. Maybe after 10 years or 15 years, the weather is going to get changed. In that scenario, if you take less, it is going to be beneficial for you, for the customer, for long run. Coldest month, wind speed and mean coincident dipole. So wind speed is 12.3 at 0.4% and 11.8 mile per hour at 1%. So here I also recommend, if you need the data, you have to use, it's better to use 0.4%, the left one. Mean coincident wind speed is 3.2 and mean coincident wind direction is in here 300. So 300 is like between north and the east. Yes. Okay. Let's focus on this. Annual cooling and dehumidification and enthalpy design conditions. Here we have hottest month. 6 months are hot in this particular city, Dhaka. Hottest month dry bulb temperature range is 10.3 degree Fahrenheit. So on the daytime, what is the highest temperature recorded on the day and what is the lowest temperature recorded on the day? The difference is in average 10.3 degree Fahrenheit for Dhaka. For cooling, dry bulb and mean coincident wet bulb temperature, we have the data as 0.4%, 1%, and 2%. Always recommend to use 0.4%. 0.4% dry bulb temperature is 97 degree Fahrenheit and mean coincident wet bulb temperature is 78.8 degree Fahrenheit. So what does it really mean? It means if you design using this condition, only 0.4% time of this whole 6 months, or better to say 12 months, um, the temperature is going to be higher than 97 degree Fahrenheit. And if you design it 1%, it means in the whole 12 months, only 1% of the time, the dry bulb temperature is going to be 95.3 degree Fahrenheit or more. And whenever the dry bulb temperature is 95.3 degree Fahrenheit or more, if you record the wet bulb temperature of that time only, the mean coincident, we get mean coincident wet bulb. The mean coincident wet bulb is 79.1 degree Fahrenheit. So remember the difference between dry bulb temperature and mean coincident wet bulb temperature. Mean coincident wet bulb temperature, it takes data only when the temperature is 95.3 degree or more. When it comes to 1%, for 2%, you have to go for 93.7 degree Fahrenheit, higher than 1%, and mean coincident wet bulb is 79.2 degree Fahrenheit. People who are more cautious with energy management always recommend to go for 2%. However, I would always recommend you to go for 0.4% as weather is ever changing. Maybe after 10 years or 15 years, it might look different. So that's why I always recommend that I always personally recommend to go for 0.4%. Now, evaporation, you're going to need this data for cooling tower selection. Remember, for cooling tower selection, you have to provide only two data to your manufacturer. The first one is the water flow rate. And the second one is wet bulb temperature of the place where you are going to install the cooling tower. So at 0.4%, wet bulb temperature is 83.7 degree Fahrenheit and mean coincident dry bulb. Meaningly, Whenever you have wet bulb 83.7 degree Fahrenheit or above, at that time only you took the data of dry bulb, and the mean coincident dry bulb is 91.6 degree Fahrenheit. You use this data for cooling tower calculation. So similarly, the data is in 1%, 2% is given in here. Mean coincident wind speed is in here. If you need it, I don't know. Actually, not required. These are all data you need. Dehumidification, similarly, for the dehumidification, this cooling, this is evaporation, this is dehumidification, and the other one is enthalpy. So for dehumidification at 0.4%, while you're designing dehumidification system, dew point at 0.4% in Dhaka is 82 degree Fahrenheit. And humidity ratio, gain per pound is 166, and mean coincident dry bulb is 89. Now, external annual design conditions are in here. So, external annual design 1% is 17.3. Let's look in here. Minimum and maximum dry bulb temperature. Minimum dry bulb temperature in Dhaka is 52 degree Fahrenheit, and maximum is 101.2 degree Fahrenheit. Standard deviation is 3.6 and maximum is 3.3. Actually, it is going to give you the whole data here. N, year return period value, extreme temperature. So N equal to 5 years. In 5 years, minimum is going to be 49.4. So for now it is, let's say, 52 degree Fahrenheit. So after 5 years it is going to be 49.4, and maximum it can go 103.5. Now the maximum is 101.2. So you can see the change here. After 10 years, it is going to be 105.5, 105 degree, 105.5 degree Fahrenheit. So the temperature is going to get extreme. It is going to get more colder and more hotter in coming days. Now after 20 years, the big difference in temperature. The coldest one is 45 degree Fahrenheit. So it's at least 7 degree Fahrenheit less than what we have today. After 20 years, we're going to have hottest summer at 107.3 degree Fahrenheit. Everything is getting extreme. So if you're guaranteeing that your system is going to last for 20 years, you might go for the data this one. However, it is going to make your life difficult if you take the highest data, because the system is going to be enormously large. Okay. Then weather data by month is presented in here. So here we get average daily dry bulb temperature for annually January, February, March, April, May, June, July, August, September, October, November. You can check all the data in here. Wind speed, monthly design dry bulb and coincident wet bulb scenarios for every different month. For 0.4%, 2%, 5%, and 10%, we get dry bulb and mean coincident wet bulb here. It is not always required. This one, also this data. This is about monthly design wet bulb mean coincidence dry bulb condition. So basically this one you can actually use for cooling tower selection. Basically, this data gives you idea, or actually if you want to calculate the system for each and every month and check out uh, the data for any analysis. For instance, let's say electricity bill. What will be the electricity bill for January? Then you can use this data and check the consumption and find out the actual electricity bill. So this data gives you the opportunity to find out things in detail. However, in most cases, while doing load calculation, cooling load calculation, we are using only this portion, only this portion. And when we are selecting cooling tower, we are only using this portion. For the humidification application, you're only using this portion. Yeah, this one, humidification. And for dehumidification, we are using this portion. That's it. Okay, that's all. You can print it out. You can find places relevant to your project. Let's say if your project is in somewhere in Middle East, let's say, right click here and you can check the nearest station here is Yasogi, Iran. Okay, just right click will open up your option. Then Bandar Mashafir, Iran, Islamic. Why I'm always in Iran? Yeah, it should be Saudi Arabia here. Uh, where is Saudi Arabia? I don't know. Oh, it should be here, right? Middle East, hot place. Okay, the nearest weather station is this one. What is this? Shahroara, Saudi. Okay, here is a psychometric chart calculator, free of cost. Pressure is given here, altitude, let's say for this particular weather station, elevation is 2363, altitude. Okay, let's just try the psychometric chart. You have to get, here we have the wet bulb temperature and the dew point temperature and relative humidity. Let's say if humidity is 60% and whether wet bulb dry, you have to put at least two data: wet bulb temperature or dry bulb temperature. Usually you get dry bulb temperature. Let's say dry bulb temperature 75 degree Fahrenheit, and you see the wet bulb is coming here, dew point is in here, all the values are in here. Very simple. Let's go back to Dhaka. Let's check the weather data which is presented in here. Mm, okay. Let's look for this one: 97 and 78.88. 97, 97, 78.88. So you get the R is 45.4%. Okay, psychometric chart. Let's look at psychometric chart. It can be done manually or it can be done using this particular software. You must learn how to do manually. Then to save time, you can come and use this calculator. Okay, that's all. Let's move forward.